Hello, welcome to this lesson. In this lesson, we are going to look at integrals of exponential functions. To start with, let's consider the function y equals a exponent nx. Every exponential function is of the form y equals a power nx, where this a can be any constant, and then the nx can be a function of x. So the question is, how do we integrate this particular function? So let's derive the integral of a power nx. Let's differentiate this function with respect to x, of which we're going to get dy dx equals, you learned in differentiation that in differential of exponential function, first we maintain the function, then we multiply by ln of the base. The base a, so ln a. Then we differentiate the exponent, the function within function, that will give us n, of which we can rewrite it as n ln a by a power nx dy dx. So making dy the subject, we're going to get dy equals dx. Let's integrate both sides. So I'm going to have integral of dy equals, the whole of this is a constant, so we're going to have integral of nx dx. Integrating dy, we're going to get y plus c equals n ln a integral of a power nx dx. Let's make integral of a power nx dx the subject, of which we are going to get integral of a power nx dx to be equal to y on n ln a plus the constant. But we know that a y from here is a power nx, so we can see that the integral of a power nx dx is now a power nx on n ln a plus c, and hence that is the integral of the exponential function a power nx dx. So with this, let's take a simple example. Let's evaluate integral of 2 power 3x plus 5 dx. Solution. So integral of 2 power 3x plus 5 dx. So let's represent the power by u equals 3x plus 5. Let's find the u, and that will give us 3 dx. Hence dx is now du on 3. Substituting everything back, I get integral of 2 power u, then du on 3. Of which you can factorize the fraction, and that will give us 1 on 3 integral of 2 power u du. So now let's integrate this exponential function 1 on 3. So it says we should repeat the function, of which we're going to get 2u on ln of the base ln 2. Then we differentiate this with respect to u, that will give us 1 plus c. So in that case, we are going to have 2, then u was represented as this, that will be exponent 3x plus 5 on 3 ln 2 plus c. You maintain the function over ln of the base, then you differentiate the function within function and divide by that, plus c. Second example, let's evaluate integral of x e power x squared plus 2 dx. In this particular problem, If you analyze the integral very well, you can see that if we represent the power by u and we differentiate, the x can be cancelled. So let's do that. So let's u equals x squared plus 2. Then our du will be 2x dx. Making the x the subject, we are going to get the u on 2x. So now let's substitute the x and u into this integral, and that will produce integral of x e power u. Then the x is now this, so dot the u on 2x, of which x will cancel x, leaving 1 on 2 integral of e power u du. And this is now an exponential function. We learned that to integrate exponential function, let's write our half. You have to repeat the function, so e power u. You divide by length of the base. Then we differentiate this. This will give us 1 plus c. We are going to get half e power u is now this, x squared plus 2 plus c. And that will be the solution. In our third example, we asked to evaluate integral of sec square x e power tan x plus 4 dx. So in the same manner, you can see that when we differentiate tan x, that will give us sec squared x. So we can let the power to be in this problem 2, so say let's the power tan x plus 4 be u. Then let's differentiate the u with respect to x, and that will give us sec squared x dx. Let's make the x the subject, and that will give us the u on sec squared x. Now let's substitute the x u into the integral, and that will give us integral of sec squared x e power u dot, now our dx is the u on sec squared x, so that will be u on sec squared x. So obviously the sec squared x will be out, which will give us now integral of e power u du. So now we have everything in terms of u, so we can integrate. Integrating this, say we repeat the function, then we divide by length of the base, then we differentiate the function within function. Here is u, and that will be 1 plus c. But not forgetting, our u is tan x plus 4, so this gives us e power tan x plus 4 on this is 1 times 1, which is the same thing, plus c, and that will be the solution for this particular problem. So try this. Integral of x power 6 e power negative x power 7 dx. After everything, the expected answer should be negative 1 on 7 e power negative on 7 plus c. Thank you very much for watching. Please subscribe, share to your colleagues too for more videos. Bye bye.